Now talking about domain, codomain and range. A part of this you have already studied in relations. Now we will be looking at how we can define these for functions. So domain is what? It is the set of all possible input values. Now what do I mean by possible input values? The values at which my function would be defined. If let's say at certain value my function's value comes out to be infinity or undefined or indeterminate, then I would say that that cannot be in my domain. That value is not a possible input value. So let's say if I was to take an example, let's say if I take 1 by x. For this, what can I say about the domain? That x should not be equal to 0. Because if x is equals to 0, this would become 1 by 0, which is undefined or infinity, right? So that is why x is equals to 0 cannot be in my domain. Apart from that, I can take any values of x in my domain. So my domain would become x belongs to real numbers minus 0. Codomain is all possible output values. It is not the output values but possible output values. Range is my all actual outputs from the function that I'm getting. So here they've shown us an example. F of x is equals to x square. So for this function here, my domain would be R. All real numbers can be inserted in this value of x. My codomain would be R. All values are possible. And range would be from 0 to infinity, because even if I put negative values inside this value of x, I'm going to get a positive value. X square can never be negative, because we know x square can never be negative. That is why we know, that is why we say that our range is going to be from 0 to infinity. So now talking about a little bit how, if let's say you have been given a multiple sets of function, so how are you going to define their domains? Let's say if there are two functions f and g, f has domain A and g has domain B. Then if you are finding out f plus g, then what would be your ultimately domain of this entire function? It would be intersection of A and B. If you have any other algebraic function between these two functions, ultimately your domain would be intersection of the domains of all separate functions. So you need to keep this in mind, because we need to satisfy each and every function so that our entire function is possible and it can have a finite value. That is why we take intersection. For f by g, again we take A intersection g, provided there is one more domain function that you need to keep in mind, that g of x should not be equal to 0. Now let's take this one for example. Find the domain of f of x is equals to root under x plus 3 upon x minus 2. So now what do we know about root under? Inside the root I must always have a positive value. I can also have a 0 value. However, if I have a negative value, this wouldn't be possible, because I cannot take the square root of a negative value, right? That means from here what I can say is, first thing is x plus 3 should be greater than equal to 0. So from here I get x belongs to minus 3 to infinity. This is the first part of domain that I've gotten. Now what is the other thing? Since x minus 2 is in the denominator, that means it should not be equal to 0. That means x cannot be equal to 2. So now I have to take the intersection of these two domains, right? I have to take the intersection, or let me write it down properly, intersection, so that I can get the domain of the final function. So ultimately my domain would become x belongs to minus 3 to infinity minus 2. What is the other way of representing this? Other way I could have represented this in this format, from 3 to 2 union 2 to infinity. This is my other way of representing the same domain. So This is how you generally find domains of functions. Now let's take this one for example. I have log, sorry, there is a printing mistake here. This wouldn't be, x plus 1 wouldn't be in multiplication. X plus 1 is the base here. So basically the question is log of x plus 1 x minus 2. So this is what the question is exactly. E to the power 2 ln x minus 2x plus 3. Of course, log with base e can be written as ln x, right? So now let us find out the domain for this function. So now what are the things that we know about a logarithmic function? Let's say if I have a x and a as my base. So what are the things that I know about this logarithmic function? That x should always be greater than 0. A should always be greater than 0 and a cannot be equal to 1, because if a becomes equals to 1, my logarithmic value would become infinite. So that is why these are the cases that you need to keep in mind. So let me simply just find out the values. So x minus 2 should be greater than 0. That means x is always greater than 2. So the first part of domain that I have found out. X plus 1 should be greater than 0. That means x should be greater than minus 1. This is the other part that I have found out. X plus 1 should not be equal to 1. That means x should not be equal to 0. Another part that I have found out. Now, if you look at the part which is in the denominator, e to the power 2 ln x. So how can I write down e to the power 2 ln x? I can write it down as e to the power ln x square, and e to the power ln x square simply becomes x square. So this becomes x square minus 2x plus 3. And since it is in the denominator, this should never be equal to 0, right? So if I try to factorize this, this would become x minus 3, this would be x minus, so this would be x minus 3, this would be a minus sign here because this entire thing was in minus. So x square minus 2x minus 3. So here I would have plus 1. This should be not be equal to 0. That means from here what I can say is that x should not be equal to 3 and x should not be equal to minus 1. So basically these are the 4 portions of domains that I've gotten. Now I need to take intersection of, so I need to take intersection of all these domains to find out my main functions domain. So x is greater than 2. If x is greater than 2, x would always be greater than minus 1. And if x is greater than 2, it cannot be 0. If x is greater than 2, it cannot be minus 1. However, it can be 3. So what would my domain become? X belongs to 2 to infinity minus 3 cannot be in my domain. Or the other way of representing this would be x belongs to 2 to 3 and 3 should not be included. So it would be 3 to infinity. That is why I'm keeping it in open brackets. Else I would have put it in closed brackets. So this is how you generally find out the domain of any function that has been given to you. And this was a question that was asked in a previous year JEE Maths. So you can see the level of questions that are asked are very easy. So now let's talk about range. So first of all, what do we know about range is that from set A to set B, if I'm mapping something, whatever value in, let's say if I have a function f of x, so whatever value of f of a that I'm going to get by putting the values of elements from set A, this would become basically be my range, right? And also this can be represented as set of all mapped elements set of all mapped outputs for elements of A. This is how I can say this is my range. So what are the rules or what are the ways of finding out range? First, what we'll do is whatever equation has been provided to us, it would be y is equals to an x function. So what we do is we simply replace the values. That means we are going to replace it in such a way that our equation becomes x is equals to function of y. Now for that function of y, we'll write down its domain, and that domain would simply be a range for y. So that is how, let me show you an example so that you can understand it better. Find the range of the function. So they've given us a function. So what we do is we represent this function in this way: y is equals to 2x plus 3 upon x minus 1. Now you need to represent this in such a way that x is equals to a function of y, and then the domain of this y would become a range of y basically. So what I'll do is I'll cross multiply this. So this would become yx minus y is equals to 2x plus 3. I'll take this x to the other side. So this would become yx minus 2x is equals to y plus 3. Here I can take x common. This would become y minus 2 is equals to y plus 3. So from here, what am I getting? X is equals to y plus 3 upon y minus 2. So from here, I've gotten this equation now. Now what would be the domain of y? It would simply be y should not be equal to 2. Apart from that, all values can be satisfied because there is no other function here. So ultimately, what does my range becomes? Range of this function or y, this is equals to set of all real numbers excluding 2. Or what are the other ways of representing this? This can also be represented as minus infinity to infinity minus 2. Or I can write it as minus infinity to 2, where 2 is in open brackets, union 2 to infinity. So simply this becomes our range of the function. So now let's look at this question. What they've given us, let f r minus 2 comma 6. Now this portion here, this is considered to be my first set A, right? And this is my codomain. So in my domain, they've told us that 2 and 6 are not included. And I hope you must have understood this, why they have told us. Because if you look at the denominator, x square minus 8x plus 12, you can see that if I try to factorize this, if I try to factorize the denominator, it can be factorized as x minus 6 and x minus 2, right? That means I cannot take the value of x to be 2. I cannot take the value of x to be 6. Else I would have a 0 in my denominator and my function would become undefined. So that is why in the domain they've already given us that. Now basically we need to find out the range of this function. So again, we'll do the same thing that we learnt. We'll write it as y is equals to x square plus 2x plus 1 upon x square minus 8x plus 12. Now let me cross multiply this. This would become x square y minus 8xy plus 12y is equals to x square plus 2x plus 1. So let me take all the x square terms together and all the x terms together. So this would become y minus 1 plus x, if I take it as common, this would become minus 8y minus 2 plus, and I would have 12y minus 1 here. This is equals to 0. So this basically transforms into a quadratic equation if you look at it carefully. What is my quadratic equation? Basically ax square plus bx plus c is equals to 0. So this is also a quadratic equation here. Now whenever you have a quadratic equation of such formats, what is generally the approach for you? You consider two cases. First case is where you consider y to be 1. If my y is 1, my coefficient of x square would be 0. Now let's say here I am considering it to be 1. Let's say if it had been y minus 2, then I would take my first case y is equals to 2, and my second case would be y not equal to 2. So basically my motive is, in the first case I want to make my coefficient of x square to be 0. So that is why what I do is I take my case 1, and my first case is y is equals to 1, and I'll check if y is equals to 1 would be satisfied in this equation or not. If y is equals to 1 comes in my domain, the value of x that would come after putting y is equals to 1, if it comes in my domain, that means y is equals to 1 is one of the solutions. It would be included in my range. So let me put y is equals to 1, this would become 0. I would have x minus 10 plus this would become 11 is equals to 0. So from here I get x is equals to 11 by 10. And is 11 by 10 included in my domain? Yes, it is included. That means in my range I have y is equals to 1. So this is one of the portion of range that I've gotten. Now what I'll do is I'll take my second case, case 2, where y is not equal to 1. So what was the equation that I had? X square into y minus 1 plus x times of minus 8y minus 2 plus 12y minus 1 is equals to 0. So now for x to have, let's say, real values or positive values, and this equation to be satisfied, what are the values of x for which I can get this equation to be 0? Of course, it needs to have real distinct roots, or it can have real equal roots. Basically, my point is that I need to have real roots, because they've told us that x belongs to this set, right, where we have real numbers. That means my discriminant should always be greater than equal to 0. Now I can understand this portion might be a little difficult for you to understand because you haven't studied quadratic equation. Once you look at that chapter, this entire concept would become fairly easy for you. For the time being, just try to remember it and grasp it. After you study quadratic equations lecture, come back to this question again and then solve it. So I need to have my x value to be real. So when do I have in a quadratic equation my x value as real? Whenever I have my discriminant greater than or equal to 0. And what is my discriminant? My discriminant is b square minus 4ac. So this should be greater than equal to 0. So from here, what is my b square? My b is basically minus 8y minus 2 whole square minus 4 times of a into c. This should be greater than equal to 0. Here I am considering my equation to be ax square plus bx plus c is equals to 0. This is my quadratic equation. So from here I am basically trying to consider this equation in my standard quadratic format. So from here, what do we get? This would become 64y square plus 4. I can simply remove this minus sign, so this would become plus 8 to the 16, 16 to the 32y minus, here I would have 12 4s are 48y square, and here I would have minus y minus 12y, this would make it minus 13y, so this would become plus 13, 4 times is 52y, and here I would have plus 1, which makes it minus 4 greater than equal to 0. So now if I try to solve this more further, 64y minus 48y, so from here first things is 4 and 4 would get cancelled out. Here I would have 64 minus 48, this would simply be 16y square plus, and here I would have 84y greater than equal to 0. So from here, what are the values that I can take common? I can take 4 common, so this would become 4y square plus 21y greater than equal to 0 this can be written as y times of 4y plus 21 greater than equal to 0. So now if I take this equation, let me write it down here. So I have y 4y plus 21 greater than equal to 0. So now I hope you all remember these things you have already studied in your school time. How can you find out what are the values of y that are included here? You take up all the zeros. So one of the zeros is minus 21 by 4 and the other one is 0 only, and both of these values are included. So you do it with a shaded circle. You write down simply plus minus plus. There is no negative sign, so it can be represented this way. For it to be greater than 0, I need to consider all positive values. So if I consider all positive values, my y belongs from minus infinity to minus 21 by 4. This included union 0 to infinity. So I've gotten my value of y, this as well as this. So is 1 included in this range? Yes, it is included. So ultimately my final range of this function can be written as y belongs from minus infinity to minus 21 by 4, enclosed in a closed bracket. I hope you all remember, whenever I write something in closed bracket, which is my square bracket basically, this means that I am including that number. If I write it in round bracket, which is known as an open bracket, that means I am not including that number. And this would be union 0 to infinity. So this would be my range. This is my answer. So this is how generally you solve questions which are related to range and when you get quadratic equations. So always remember, solve using two cases. First case is where you are considering the coefficient of x squared to be 0, and second case where you are considering it to be not 0. That time what you have to do is you have to put the discriminant as greater than equal to 0 so that you can have real values of x.